Hello guys, welcome back to Abstronic tutorial. The discussion how the AC-DC power supply working. As you can see, we have step-down transformer. The output is 12 volt, 1 amp, and a full bridge rectifier diode, and the capacitor connected to the output of the diode. Also, the resistor connected from the output parallel to the capacitor. All the rated value of the component must be greater than the output of the transformer. The diode is 1N4001, and these two diodes working on positive cycle, and the current of each diode is 1 ampere. So therefore, since they are working on the positive cycle, the current rated must be add. So 1 plus 1 will be 2 ampere. So 2 ampere is greater than the rated current of the transformer, which is 1 ampere. And the voltage of the diode is 50 volt, also greater than the voltage of the transformer, which is 12 volt. You can use any electrolytic capacitor as long as the voltage is greater than the voltage output of the transformer. Using the high capacitance to improve the output performance, you can place any value of the resistor as long as the wattage can handle the output current. So let's place the 100 kilo ohms resistor, and let's calculate the current flowing through it, and also calculate the wattage. So using Ohm's law, voltage equivalent to current times resistance, then simplify current equivalent to voltage divided by resistance. Then substitute current equivalent to 12 volt divided by 100 kilo ohms. Then the current equivalent to 0.12 milliamp. Now we can calculate the wattage of the resistor by using the power formula. Power equivalent to voltage times the current, or you can use power equivalent to I square times the resistance. Then power equivalent to 12 volt times 0.12 milliamp. Then the power equivalent to 1.44 milliwatts. So you can use any wattage of the resistor as long as the wattage is greater than 1.44 milliwatts. So this time, let's discuss how the component is working. The job of the transformer used to supply the current through the entire circuit in the form of AC. The job of the diode is used to convert AC into DC. But how the diode converting AC to DC? Simply like this. During the positive cycle, the current flowing to the input of the diode and going out to the negative side of the diode. So let's review again how the current flowing during the positive cycle. During the positive cycle and the positive cycle blocking by the negative side of the diode, at the same time the negative cycle blocking by the positive side of the diode. Then the positive cycle entering to the positive side of the diode and going out from the negative side. At the same time, the negative cycle blocking by the positive diode and entering to the negative side of the other diode and flowing through the negative side of the capacitor. As you can see, the positive cycle entering to the positive side of the diode and going out from the negative side of the diode. So meaning, still positive cycle going out from the negative side of the diode. That is the reason why the positive of the capacitor connected to the negative side of the diode. And the positive cycle charging the positive plate of the capacitor. So when the alternating current alternating from positive cycle to the negative cycle, then the polarity and the direction of the current is changing. So now we have two positive cycle and two negative cycle. So let's review again how the current flowing during the negative cycle. During the negative cycle, the current flowing counterclockwise, flowing from the negative side, going to the positive, entering to the diode and blocking by the negative side of the other diode. Also, blocking by the negative side of the diode from the output. The same thing from the negative cycle, blocking by this positive side of the diode and entering to the negative side of the other diode, also blocking by the other positive side of the diode, then going out, flowing to the negative output. Then again, the positive cycle repeating the current flowing through the input of the diode and going out from the negative side of the diode and flowing through the positive output. Now we have 3 positive cycle and 3 negative cycle. In the actual circuit, the negative cycle does not flowing through the input of the diode and going out from the positive side of the diode, then flowing to the negative side of the capacitor. But in this circuit, I'm doing this just for demonstration how the negative cycle connected to the negative side of the capacitor. So there is no doubt every negative cycle, the negative always connected to the negative side of the capacitor. The current flowing only to the negative when there is a load from the output of the power supply. Now, let's discuss how the capacitor is working. The job of the capacitor is to reduce the pulsating DC came out from the output of these two diodes. So what is the pulsating DC? The pulsating DC is the positive cycle came out from the transformer and entering to the diode and going out from the two negative side of the diode. Since the positive cycle came out from the transformer and the transformer, the output voltage is 12 volt, so therefore the maximum peak of the amplitude of the positive cycle also 12 volt. Since the output of the transformer passing through the two diode, then the maximum peak will be 12 volt minus 2 times 0.7 volt, which is the internal voltage of the two diode. Then the maximum peak will be 10.6 volt. Initially, the voltage is 0 volt, then increasing to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then again, dropping from 10 to 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. During zero voltage, then the amplitude will be in the off state. So when it begin rises, then the amplitude will be the low voltage state. Then when it reaches to the maximum peak, then the amplitude will be in the pulley state. Since the output is not stable, always shifting from the off state to the low voltage states, then the output of the rectifier diode is not ideal for any electronic circuit design. The only solution to solving the output problem of the rectifier diode is the capacitor. So let's connect the capacitor and let's see what happened to the output of the rectifier diode. As you can see, the signal output from the capacitor, reducing the pulsating DC came out from the output of the rectifier diode and filtered only the high voltage and removing the low voltage. This is the reason why sometimes we call this as filter capacitor. Because of the capacitor, the output almost stable, but there is a little DC pulsating, and to remove this, we need the voltage regulator. The job of the resistor used to stabilizing the output voltage and also discharging the capacitor when the power supply turning off. That is how the AC-DC working and all the components in the circuit. So this is the end of my video. Don't forget to subscribe to my channel, like and share. So thank you for watching my video.